Excellent. All right, I'm going to start into a patch set that I just recently submitted today. This talk is about XSM and role-based security for Xen. All right, so the purpose of today's talk is to, like I said, was to go over the patch set that I recently submitted to the Xen Devel mailing list. As the objectives of this talk, as we dive into this, is I'm gonna go over the context and the motivation of the XSM roles work. We're gonna kind of dive into what the major functional areas of responsibility within Xen is today. Identify what the distinct roles for domains within those that take those responsibilities or delegated those responsibilities. Kind of establish a base understanding of the security controls in Xen today. We'll go, and from there we'll go into what exactly is XSM, and then explore how that drives down.
All right, so the motivation behind XSM roles. I'll try to speed up a little bit for the last time, I apologize. So this kind of started out as we were working through Hyperlaunch, the design sessions there. One of the requests we received was to do a work to formalize what the control domain was in the hardware domain, because that was one of the motivating factors for Hyperlaunch, was to enable launching systems with this separation. While looking at that, or during those discussions, another aspect that was pointed out was the pass-through privileges were actually split. So the PCI pass-through privileges were actually split between both what is the hardware domain and control domain as it's defined in the kernel today. So we went down this path of looking, how do we resolve this? How do we enable this for Hyperlaunch? And when we were looking at the is control domain and his hardware domain specifically, a couple of conclusions were drawn. For one thing, Xen already had a loosely defined role-based access control model in it. And two, there was a little inconsistencies on how that was implemented throughout the hypervisor. And so a larger overarching view of these functions that a domain could perform needed to be abstracted and provided in a concrete manner. So that is what started the path down to XSM roles. So to understand this, to start taking a look at the security controls within Xen today, there's actually two sets of security controls. One is the type of domain checks that you have throughout the hypervisor. This is if you've been inside the code, you've seen it. It's the is control domain, is hardware domain, and so forth. I believe there's actually a couple more that I didn't capture here. But the idea here is a lot of these are not necessarily privilege checks, but just checking for the role that a domain is functioning in, so that way it can be decided on whether or not an action was appropriate. And then there's the fine-grained XSM control checks, or the XSM hooks, that are distributed throughout the hypervisor itself. And these hooks are what's used to enable one or more policy modules, which are the two more well-known, the dummy policy and the flash policy, and then as well as the silo policy. The dummy policy is not exactly what I think is an interesting one. Some people may not be aware exactly how that one is working. So that brings us to what are the roles, after looking at all this, what are the roles, core responsibilities that's in the Xen platform today? And so, kind of walking through this is what I kind of distilled down to. So there's the platform host itself, right? That is the entity, and what you need to be able to do with that entity is you need to be able to manage it. So these are your general operations to manage the host: set up boot, EFI variables, manage power management, and things that happen at the platform level that's not necessarily specific to a single domain. Then there are domains, and within for domain objects, you have construction, deconstruction, or construction, and then you have the lifecycle management of them. And these are fairly straightforward, or the construction destruction is fairly straightforward. The lifecycle one can get a little fuzzy. What we wanted to stay focused on is that lifecycle management of the domain is to manage its running state, whether it's running, it's paused, what its runtime configuration is, what devices have been configured for it, hot plugging those devices in and out. So these operations that are managing what is happening with a domain. Then you get to the virtual hardware that's being provided for the domain. And there are actually two types, right? There's the emulation and there's backend drivers, device driver domains. So I think this is pretty straightforward. There's the role to provide emulated hardware for a domain, and then there's the role to provide a backend driver for one or more para-virtualized devices that are attached to the front ends in one or more domains. And then you have the physical hardware. And so when you look at the physical hardware, this is the other one that we took a little bit of reasoning about. So the first role that a domain could be doing with the physical hardware is provisioning and deprovisioning it, preparing the hardware and discovering the hardware, preparing it so that it can be made available to the hypervisor to provide as a pass-through device to a domain, and then as well inform the hypervisor when the hardware is no longer available and take care of the takedown process. Then you have the lifecycle management of the physical hardware, and this is the one where it became a little fuzzy, right? Because how much of this is really about managing devices versus managing the access of devices to a domain? And really what we wanted to focus on here was this is specifically the adding and removing of the hardware to a domain, ensuring the hardware is in a good state before and after assignment, and the general care and feed of the hardware itself when it's not being managed by the domain. So with this understanding of the roles that are possible in Xen, now let's take a look at how XSM itself is set up today. So when the XSM hooks are always present and they're always invoked within the hypervisor. When you build Xen and you have the XSM kconfig option disabled, the dummy policy header file, which has a one-for-one definition for every XSM hook in the hypervisor kernel, gets included directly into xsm.h, which is then how those hooks are, the backend, the implementation of those hooks get called. When you turn XSM on, instead of that dummy header being applied to the xsm.h, the dummy header actually winds up getting put into dummy.c and called as hook functions as opposed to just straight static inline function calls when you turn it off. So as far as the operation itself, the operation is exactly the same. It's just whether or not the invocation when it comes to the dummy policy is whether it's called directly or called through a hook or through a function reference. So it's taking that understanding and realizing, okay, the dummy policy somewhat recreates that same role model that is pseudo present inside of the hypervisor today. So let's take that, solidify that. So when we start to walk down deeper, right? So we know what the general roles are. We see how XSM is hooked into the system for the dummy policy. Now we look at what that dummy policy did in terms of what a control domain can do and what a hardware domain can do. You see that you got this mapping that today the control domain is granted all responsibilities when no home hardware domain is present. When the hardware domain comes along, the physical hardware provision, deprovisioning roles the hardware lifecycle roles, and the virtual hardware emulation all are from the control domain to the hardware domain. And so the dummy policy just continues to enforce this. So when we're looking at and diving even further into these details as far as this goes, as far as XSM is concerned, you get these fine-grained control checks, and the selectable policy comes in and makes access control. And as I highlighted, so these hooks are all the way through the hypervisor. When these hooks are called for the dummy policy, they're called into a dispatch structure to get you into that hook call. And then the XSM4 is just an initializer that helps set all this up for you. And then you have the policy modules. Like, I'm highly focused on the dummy policy because that's what we're actually involving here, and as well as the silo. But each of these have their own hooks into it. So what is XSM roles now? Now we have kind of laid into the detail of how XSM is working, how we have is control domain and is hardware domain, implicit checks. What we did is we came up with XSM roles, which is to create a coarse-grained role-based access control mechanism. And I highlight that very strongly. We are not trying to create anything of finer grain control than just a basic role assignment solution. If you want finer grain, do not be using XSM roles to do that. This is where Flask is really the preferred and highly recommended if you want to do much finer grain control over what domain has access to what resources in the Xen system. So when we do this, and we've looked at all of this work that I've kind of quickly stepped through, one of the things that was identified is that we have these implicit and we have these explicit roles that a domain can fulfill in the life cycle of the Xen system. The roles are not fixed to be a one-to-one relationship with a domain. So a domain could have one or more roles or no roles within the system. A role could be assigned to multiple domains, where it all makes sense. And there is no concept of delegating these roles for those that think about capability systems, where you can delegate a capability to a child. That is not what's going on here. This is a very straightforward role assignment. You get a role, that's what you do. You use it to take care of the operations you need to do, and when your life cycle ends, the role is relinquished, more or less. So implicit roles, when we were diving into the dummy policy and working out exactly how all this was working, there was these ideas of a target or self, when a access control check was happening. So there were certain operations that a domain was allowed to do to itself, and there's certain operations that if a domain is trying to do an operation on a target domain, and that target domain is referenced in its target handler, it could carry out that operation. Then you get into explicit role. And an explicit role, that is clearly a assigned operation that you're doing a specific check for having that role at the policy checkpoint. And so this is kind of how we split up these roles as we were laying it out into the system. As I highlighted, right, so there's these implicit roles, and as I talked about self and target, but there's also the none role check, which is that you didn't need any role at that checkpoint to do that operation. As I covered, the self one is if the operation is allowed to be done on the self, it's allowed to go through. If the operation is done, needs to be carried on against the target, and that's your target domain, then you're allowed to do the operation. Then you get the explicit roles. And as you kind of could see when we hinted at the beginning, when we kind of generalized the the general roles in the system, we came up with these explicit roles that is pretty much a one-to-one mapping to those. So platform control is the platform management. Domain builder is the responsible for domain construction and deconstruction and destruction. And especially since reboot is pretty much a destroy, recreate, that means the domain builder role is necessary to reboot a domain. Domain supervisor is the one that's looking out over all the domains, doing the lifecycle management over the domains. Device emulator is the one that's providing an emulation, device emulation for a domain. Device driver maps out to the PV backend. Hardware control is what actually is responsible for allocating the hardware for domain usage. So that's that hardware lifecycle, or I'm sorry, hardware setup. And then the actual assigning and managing of the hardware after it's been provisioned for usage is the hardware supervisor. So from a top level implementation, so this is what, so you saw how we did how XSM works today when you build it. With the XSM role patch, what we've done is all of the inline function checks that were in the dummy.h mutated and went directly into XSM.h and are the actual default calls for every XSM hook. There is no the functions are always the ones that are called when the hook is called. What it does for each of the hook function calls is it checks to see if there's been a hook registered, an XSM hook registered for that call, and the available XSM hook. And if it is, then it'll make the call make that call to make the access decision. If it's not been registered, then it falls back and does the XSM role check. And then in role.h, we took out the default action routine that used to be in dummy.h, and we brought it here so that way this is the role policy, the static default role policy for this. And so this will actually make all those role decisions as the XSM hooks are made invoked. So what's the intention of all this? At the end of the day, what we will be moving towards is that in the past, XSM had this pseudo state of was supported and wasn't supported. Silo was supported, but XSM wasn't supported. But you need XSM on to turn on Silo. What we want to move towards is getting back to what you are accepting as being supported is just there. It no longer is turned on and off. It's just always present. And then we can worry about the actual policy modules, the silo policy and the flash policy, whether or not you want those enabled, and those can be individually be in a supported or unsupported state. One other thing we did as we were doing this is we recognized that the silo policy really is just an extension of the roles, just a restriction on the roles a little bit. And so we actually converted silo to be an extension of the roles policy and demonstrates how that can be done. So from an internal implementation standpoint, the way XSM roles works is that we assigned a URINT32 to the domain structure called XSM_roles. It allows us to have 32 distinct roles available within the system. I don't think we'll ever need that many, but it's still, because it's a far more than what we have today, but at least it leaves it open for growth if need be. We went into the is control domain, is Xenstore and is hardware domain checks, and we converted them to leverage the XSM roles bit tilde to make those decision points. So that way, when you're assigned the role that is effectively the control domain or role, set of roles, if it's more than one that needs to be defined, that check has now been converted to inspect that. The one exception is hardware domain. It not only does it check that the bit tilde is done, but to ensure that we only ever have one hardware domain at a time, there is a global reference. This is to help speed up because this hardware domain is called many times throughout the kernel, so we do not want to have to do a check, find the domain, or when the hardware domain is needed to do a check, it used to just pull a global reference for it. So we kept that global reference there, but we actually added a double check there that the domain does match the global reference and it does have the bit built in its hardware domain check. Its system domain, its idle domain hasn't been converted yet. It's kind of beyond the initial scope of what we were intending to do, but it is within reason to potentially convert that in the future. And as I said, we went in and all the XSM hook underscore, whatever check is being done, we converted them all over so that a way the default is to, if there is an operation defined in the XSM ops structure, then we make that call. If not, then we fall back and we use the check to the roll check to see if it's allowed. What else did I start? On those checks in the past, the way it used to be done is that there would be a default crib that was passed when the hook was done, and you could only pass a single one crib. With this change, the way we've done it is now you actually pass a mask of the roles that are allowed to make that hook, so that way we can now have that flexibility of a hook being pinned to just one domain role. Got a few minutes left. All right, I got to blow through these. I apologize. How do you use it? So you don't need to do anything. With the purpose of XSM roles was not to change the existing behavior. It was just meant to solidify the roles and formalize them within the Xen system today. When Hyperlaunch comes available, the Hyperlaunch will be able to have access and assign the domain roles as it's doing the instruction phase. I didn't put it on here. One of the things, that's in future work. I'll say that for that slide. Sorry. So what does it do? It doesn't do anything today that you will see. It doesn't change any public interfaces. It doesn't change any behavior, or the intent is not to change any behavior. That's why it's an RFC right now. We need to validate that we didn't change any behavior. And it's the foundational work to help enable, better solid definition of Xen security controls, bring some cleanup to the security code, and enable Hyperlaunch to do disaggregated start at startup. Short term, we want to address changes that may need to be done to enable disaggregated launch. Longer term outlook, we want to look at some of the XSM hooks that didn't have explicit role checks on there, get those added. We can look at maybe exposing this through hypercall, so that way you can do role assigned domains could be assigned roles by the tool stack, and eventually get more of the XSM policy modules. So in closing, I want to thank Star Labs, Adam and Scott. They've been supporting and sponsoring this work. They've been great and encouraging us to get this up there. And then a big thank you to Christopher and Andy as I'm tearing through this code and tearing through all the code and trying to figure out how it all worked and going off on crazy rants and asking silly questions. They were very helpful and all of that. So with the very little time I have left, are there any questions?
Have these patches been posted yet?
I'm sorry, what was that?
Have the patches been posted yet?
The patch is up. Yeah, it's out on the mailing list.
Okay. Cool.
There's a link at the beginning of the deck. So if I can get back up there. So there's the links to the actual patch set.
Right.
So yeah, it's out there. And as I said, I released it as an RFC. It compiled. I did my best to make sure that it could be that each patch should build on its own within the patch set, so you can checkpoint the work if you find a bug, or more specifically, if I can checkpoint the work to trace down a bug. But the key point was just to have a nice clean patch set that I know compiles and can boot. And I launched a system and then ran some XDF tests on top of it to make sure that at least some level of it worked.
Yeah.
So your mileage may vary. I have one platform that I did it on. So
yeah, so the talk was really informative. I'm sure it'll help in looking at the patch set. So
yeah, and the patch set I actually I broke it up into two stages basically. So the first part is I kind of converted over to roles and applied those roles through the existing system, and then once I got that working, and I did some minimal testing to make sure it was that I could get a system booting and do some minimal commands to the hypercalls. I then did the full conversion over of converting the dummy policy into the roles policy. I did throw up earlier, not too long ago, a design session for this. So if people want to ask more detailed questions and take a look at the patch set with me, if it gets scheduled, we can do that. Just express, if you're familiar with the design sessions, go express interest in doing it and see if it can get scheduled this week.